Hello, welcome to another ROM hacking video, where in this video we are going to be doing something a little bit different in that I don't know what we're doing. Yay! So if you remember from last time, if we build the project, everything works except for the power patch comparison. And when we run the comparison, the only difference is the checksum, which, to be honest, I am pretty sure that our base ROM actually has a bad checksum anyway. So, for the purposes of just being able to get on with the makefile comparison nonsense, I'm going to open the base ROM that I'm comparing against and patch those values to match. If I go to, I hate how the comparison tool gives all of its offsets in decimal. Okay, this is 27EA. Or 1F27? I don't even know anymore. The byte that is 37 or 25. Wait, none of these bytes are 25 because I'm reading them in the wrong order. Okay. What about 122? There's 7A. Huh? So what happens if I set this to 2F and save it? Okay. So that is the right byte. I'm going to set you to 7A. Save you. That is still wrong? I entered in 122 and now it's 172. Look, I am literally changing this byte just to get closer because for some reason either this calculation is wrong or the compare thing is just completely off. I don't care. Someone's gonna just laugh at me. Ha, why are you even using this stupid tool? For the record, this is not in any way the correct way to patch a ROM. It's just that I am too lazy to figure out how to use RGB fix correctly. Okay, project builds correctly now that I have a valid checksum on this. Remember how we said we hand assembled our patches? Okay, so this is a different comparison. Telefang PW English and base ROM patch. The difference is the Telefang patch is just building the patch on top of itself. PW English is building the patch on top of the Japanese ROM. So this different comparison lets us measure how close we are to having fully disassembled this thing. And that is way too many lines. Yes, I am looking up this shit. I think it's head N20. Okay. So, we have some things in the header somewhere, pre-header area. Let me get the latest translated version to go to 64. And these are null bytes in the original ROM, which I don't know what they do. Let's see if someone documented them, maybe? This is all the text banks, which I still don't know how we're going to do text injection. And in fact, I might have to figure out how to get the comparison tool to avoid talking about text, because that changes so often anyway. Or at least it would, except for the fact that we don't really have a translator at the moment, because our current one is busy with schoolwork. Extra jump into reset vector for some reason. Yeah, that's very helpful. Okay. Call M? I don't think we use the M flag. I mean, I've never seen any other code in this entire thing use that flag. The M flag is not... Yeah, there is no M flag. So I can say that this code is... oh, wait, there's another byte here. Jump to location FC, undefine all this. Oh, okay, so this is actually a string. For some reason, it just says Denju A. This jumps to FC. I don't know anything that uses this vector, but I'm going to disassemble it for completeness. And then there's a NOP slide to 150. This just resets the entire game. Okay, I have no idea what this code is supposed to do, or what even calls it. And in that case, what I can do is pull up... I'm going to have to blur this out. If I can find... There's my copy of BGB. So another thing we can do is use an emulator to determine if something has been executed or not. So we are going to load Telefang Power... No, we want the the one that we've been working on. So I'll load up this patched ROM, and it's going to go off screen. We're going to pause it for a moment and open up our debugger. Where's our debugger? Hello? Okay, apparently debugger does not load when the ROM is paused, and the debugger does not update for any reason whatsoever. That's great. What we need are access breakpoints. So if we put an access breakpoint on address 63 on execute or on read, add, what that will do is cause the debugger to break when it encounters anything that uses it. Why are we still paused? Unpause, thank you. Oh, what the heck? Someone actually patched that screen? I did not know someone patched that intro screen. That's actually good. Okay, so our debugger is either broken or this code does not get executed through most of the starting routine. I mean, I could play the whole freaking game to find out, but I don't feel like it. And we can't just use... See, here's the thing. IDA has this nice thing called auto-analysis, which doesn't work because of banked ROMs. So all I can really do is actually write code here to cover that stuff. The frig? Why is there a G folder? That's not even valid. GTFO brackets, just GTFO. Okay. This is going to be a system thing. Entry points, this covers... this covers RST vectors. I'm going to call this patch utils.asm. I'm fairly sure this isn't even a valid RST. Yes, this 63 does not get used for anything. Which I'm not even sure this is the correct way to reset the game, because if you do it this way, the A register is going to be clobbered. Actually, hold on. Does this even... I mean, it has a jump to the main routine, which sort of makes sense. I mean, could this be interpreted as anything else other than this? No. Nope. That's definitely code. So, I guess I gotta actually add in... Yeah, there's actually a fair amount of space in before the ROM header, which they can't... Which is there because of hardware things. When the Game Boy boots, the first 100 bytes are occupied by a boot ROM. So if it needs to read from the cartridge, the header has to be after that. So there's this 100 bytes of actual code that... Actually, no, there's the RST vectors and interrupts, but that only takes up 0x60 of 0xFF bytes. And, oh, hello, this goes straight into the ROM header. Then put a comment saying, further execution hits the main vector of the ROM header. Make. Oh wait, that's not going to work because I didn't put it on the make. I hate make files. Alright. We have a differences at 109. What's at 100 that's so interesting then? Why is this not getting added here? 109 is the wrong byte for some reason. 6D. Oh, I have to add a null byte? Seriously? Why is there a null byte there? No, that didn't cover it. 6E. Okay, what am I overwriting here? Oh, I think I know what this is. A while back, someone added a utility for patch utils limit break. Yeah, this is literally just a generic way of changing the size of fixed tables. So basically this doubles anything. You replace if you have like a thing that's calculating addresses, you'll have a SLA, ERLD chain. So you just replace the last two with a call to this. Slarl. That's what I like to call it, because it's SLA, RL, slarl, slarl, slarl. And that's how you multiply. Shift and rotate repeatedly. Okay. And I should probably name that little subroutine. Now I can't use that name. I just named the thing. Wait, hold on. I think I know what's up. This is... What the heck? Okay, now this is stuck as... something. No, that is sub 10. Okay, can I please use... There we go. Just trying to make this into... For some reason, this is already part of a function, and splitting subroutines in IDA is such a pain, I'm not even going to try. So none of this should be broken. I shouldn't be getting errors on 109, which is 6D, which is supposed to be a null byte. Go to our base ROM. What? Oh, Oh, what the heck? Alright. I don't think this is ASCII at all. Load byte FF00A. Well, that is a valid instruction. I don't know if it gets used, but it makes more sense than having an accent. I'm gonna say that's as good as we can get for now. I don't have any idea about the semantics of that code. Alright, we are now up to byte 120 in our completeness check. 120. Okay, what is that 120? 78. Is it, are you code? Oh, yes, you are a fairly significant amount of code, which actually does stuff with the main script routine. So, this says PC10, read the tile mode. Did I ever document what that did? No, but I think I remember somewhere. I really need to update some of these maps. Like, these names are from old disassemblies and grap and 3AA7. Oh boy, we put stuff at the end of the ROM now. See, I would like to know why this whole thing is, I mean, why it's in this and not the actual bank for this code. Home bank space is very limited. HL pop inc a. No idea what this byte is. I'm going to assume it was allocated. Let's see. CB2F. Nope. Not in there. There are CB2 stat text num letters drawn. Draw status text. Okay. Why is there a banked version of this? It's a home bank routine. It doesn't need a bank. But this gets called from. See, now I'm just trying to figure out how am I getting off calling this status text? I have no clue. Oh boy. Can we get BGB back up? Load our ROM in, open up the debugger, hope it doesn't bug out again. Set our access breakpoint on 3A91. On reader execute, add. Fun thing, we've actually done interviews with one of the monster designers for this game, which was pretty freaking cool. So, status text might mean, like, in a battle, as in I have to actually go through the intro, and the funny thing is this intro sequence, like this part right here, the second thing I did to this ROM was just figuring out why those letters were not rendering with the variable with font. Everyone was like freaking surprised. Like they thought it was going to be this amazingly difficult thing. I'm like, nope. Just have to change this one byte here. At least I think that was how it worked. So we are going to just... Oh, hello. Alright. So this does get used as... Why the frick are you not rendering? Like, if I take you onto another monitor, still are not rendering, which is great. So, does the VRAM viewer work? You've gotta be kidding me. This shit worked at some point in my life. So, I know this gets used, and it gets used on the screen where you get a monster. And now I can't even quit out of BGB. And that's about it. So, I'm not sure what status this is referring to, or even what module I should call this. All I know is that this particular byte gets incremented in this function, so it has something to do with this code. Somehow. CP2F is... Now, let me run that through again without the debugger, because apparently the debugger is just completely unusable. Okay. Actually, first, let's go graphics. order disabled, LCD, white point, gamma. There is probably something in here that is causing all this weird crap. Or actually, you know what? Let's turn on the legacy display scaling. Maybe it really doesn't like seeing a high-res thing. Now everything looks all blurry, but whatever. Does our VRAM viewer work? No. Doubler, BPP, output. See, this all affects the actual way that the ROMs get the ROM data. Sorry, not the ROM data. The way that the ROM's graphics get presented to you, but it doesn't affect like the UI. White space reduction. Font. Actually, can we change this like Anonymous Pro? No. Can we change it to Adobe Source Code Pro? I think that's what the special Adobe source code font is. That sort of works. Turn off white space reduction. Pause, and VRAM not working. What the frick? I can see this part of the VRAM viewer. Maybe if I... Okay, OpenGL. Yeah, that's gonna start going into its track loop now. Oh my gosh, what is with all of this? Just... start and debugger, lowercase hex, CPU usage meter, it's interesting. That's better than nothing. I still can't see, like, background color is white, text color is black, highlight should not be white, maybe gray. Like, it's not even like it's the color is wrong, it's literally clicking it does nothing. Oh, what the heck? Okay, that is even worse. When I enable triple buffering, if I hold down page up and page down, I can see something. Can't make this do anything still. Okay, I am unable to get that working, so eventually I'm going to have to just like replace that version. I mean, this is an older version of BGB. It could be like there's a later version that doesn't screw up on Windows 10 or whatever. Okay. Rename address. We're going to call you, until I have a better naming scheme, they're going to be called status text underscore number of letters drawn. I'm not even going to bother symbolizing this. I'm just going to add... I'm going to call this mystery code woo. So I know what this bit of code does. It's resetting the VWF so that the next thing that uses it overwrites the compositing area that the tiles get drawn into. I'm pretty sure this is adding VWF to status text, whatever status text is. Then there's this location 93, which gets called from this other freaking mess of code. This is just pop BC JR88. So let's see what this other half does. Worst naming ever, I don't care. Now, E0 is the start of the control code range, but E0 is also a specific control code. Dot 3AB6. So that is basically the start of this whole freaking thing again. And while we're here, name this. So my disassembly makes a little bit more sense. 3AB6 is this chunk at the end that calls 93 for some reason. So once the patch is fully disassembled and I can more confidently move things around, then I'm going to start worrying about the like moving all this stuff to places where it actually makes sense. Because this is basically, as far as I can tell, replacing an entire letter drawing routine with the VWF stuff, I think. So that just jumping. Who assembled this? Watch. It's probably gonna wind up being me. Git blame has a habit of coming back to bite you. Okay, so this jumps back into... I think this might actually be the start of the routine. Well, wait, what the... This only gets called once. I don't even know. We're just gonna call that .exit. So we have... It jumps to the header to initialize a loop, check the old tile mode, determine if we need to increment the... if we need to move forward 16 bytes on BC or not. So what does this do? To FC7. Banked draw letter. Did we disassemble banked draw letter? Did we come up with a better name for it? Put up our symbol map and answer is no. So that is something I am not going to worry about just yet. So it looks like whatever is in DE serves as like a loop variable, I think? Or not? No? Maybe? What is DE? Well, in any case, I'm not going to worry about it. I'm going to say... I think this is just looking for the E0 control code, which, if we go here, we will find out that E0 is our end of string, which is supposed to cause the control code interpreter to relinquish control back to whatever state entered it. So we're just going to call this .exit. Okay, this jumps back to the beginning, loads BC with a thing, checks to see if we are on the second bank. If so, we're going to call this second composite tile, PLZ. No, that's a horrible name. Good thing I added that. Good thing I got that thing working where I can jump across banks. Sorry, not across banks. Across labels like this, which is not going to be fun for anyone looking into this and wondering why it won't build on standard RGBDS. This basically, we read the next letter from DE, draw it to the screen, then call some other thing in the header that determines what mode we're in, if we need to patch up some things, increments this other byte that we don't even have a symbol for, so I'm going to have to use an equate for now. Then we jump back into this. So, aside from the fact that the logic for this loop, the placement of this loop is just completely bonkers, it's fairly standard. So I'm going to change this to part of a function that replaces status text drawing with the VWF. And run through our correctness. CB2F not defined. Okay, that's good for now. I'll have to add the banked draw letter in a moment to the other branch and then rebase and fun stuff. Okay, Telefang PW English differs on 151, which is better. So 151 is 97. What the heck? Okay, 96, because the comp routine is totally bogus. This, okay, I don't even know what this does. don't know what this does. And this is just a NOP slide into other code. Is this even code? So these appear to be RST10 is our bank switch thing. So this switches to whatever bank is in A, calls the thing, and then switches to whatever is in A again, which I don't know what this is. I am just going to add all of it for the time being. Mystery code woo. And we are just gonna, I'm just gonna disassemble the rest of all of this for now. And once I disassemble code that calls it, then I can actually name it D0. Oh wow, that is deep in the ROM. So what does this appear to be doing? Like, checking if HL is within a certain value, and if so, that's just another mystery. I should put a to-do here. Spoiler alert, no one ever reads the to-dos. Like, ever. Right, that is the end of... There's like a freaking NOP slide? Why? Like, why not just move this here? Yay, NOP slide! Then I technically can get rid of this. Alright, where was I? Sorry about that. People are so, inconsiderate of the fact that I'm recording video in my room without telling anyone. I don't know what is that D7 either. I think this might be to do with some bank redirections that may have been made at some point in time to move things around. Because not everything has not all nice meta tables and all that fun stuff. The half carry flag? I mean, sure, it is valid, but who is doing BCD math? Oh. I seriously misread that as a flag as opposed to a register. Otherwise, call 548. What is 548? Load Denju name. I'll have to come up with a better name for that, but other than that, it's JRF1. Then we have that thing here earlier, and bam, that is all the patch utilities in one massive blob. This should cover everything in the pre-ROM header area, except it's going to not like it. It's 46. Okay. We effed up something in this disassembly. I like to imagine this is all for one specific bit of code, that they're just redirecting crap. Okay. Good news is we are actually out of the pre-ROM header area. And we do have a couple more differences in the home area, but I'm going to restrict that to another video. So yes, thanks for watching, and hopefully a new video will come shortly. 2 months later. Hello, this is another ROM hacking video with an annoying air conditioning unit in the background because of logistical problems that I absolutely don't feel like solving. So, in the past 2 months since I've recorded a video, Sankey pulled my patches and everything upstream and made some changes of his own. So it's time to see now what exactly is still in our setup. And I'm going to forget what my make command is, and then my computer is going to be a pisser. So, wait, are all these differences just in the The hell? Okay. So it appears that we have got some sort of breakage, not in the the base ROM completeness check, but in the correctness check, which I'm going to type incorrectly. 1E4COA. So the question is, where are all of these additional things coming from, and why are they screwing up my check? 5 minutes later. Wait a second. Okay, no wonder there's nothing here. This is counting in... Why would it count ROM banks in decimal? Makes absolutely no sense. I'm going through every freaking map trying to find bank 79 when it's actually number 121, which has a 3,000 byte section with nothing in it. That's great. Anything reference bank 79. Phone keypad graphics, which includes a lot of junk. Maybe that's our deal, but problem is that this thing was in fact tinkered with. And these were changed. In terms of purity, I would like to be able to have a quote-unquote pure version of this patch before we start making modifications to it again, but I can see why these are different. Why is this called solfege? They're katakana buttons, obviously, but whatever. Who cares? So, I am going to remove the correctness check for now, since it does not appear to have given us what we want. Or more specifically, I need some way to only analyze what I deem to be not supposed to be changing. Alright, compare power failed. And that's going to give us compare power English and base ROM patch. Wait, what? Oh yes, this is the completeness check. It is wonky. Alright. This is the part where it's completely obvious that I am not qualified to be using this software. So, the real start of the video, maybe I'll edit it out, maybe I won't. We need to start investigating from 1353 onward, which if I hadn't completely shit-canned that calculator, I'd be able to tell you that 1353 is byte 549. Which is load denju name. I hate how IDA does not appear like it should. 548. So that has been patched. Load denju name with our generic I believe this is the generic limit break. Going to help because I didn't put it in there. I swear I put 90 in here. None of this shit helps. What the hell? Did I seriously? I distinctly remember disassembling this. I'm sure somebody watching is laughing at me, saying, haha, it's right in front of your face, idiot. And they would be right. Here we go. Patch utilities. Okay, I think I can actually give a name to this sort of mystery block. So if it's not the start of the banked ROM area, then go to bank 34, otherwise go to bank 75. So in the original, it would go to bank 75, load from that ROM table, and return. Here it does something a lot more lopsided. This is getting a name. That's not a good name. That's a slightly less horrible name. Yeah, who cares about the name limit? It's 2016. So I do not believe I disassembled load denju name. Survey says no. Which means we get to do some git crap. It says roughly what it does. Might do something even dumber. I don't care. Go back to master. It doesn't like my changes to the make file. Go away. Go away. Go away. Alright, so we have to start disassembling name table utilities. I'm going to call them name table utilities. There is a lot of, right above this, a lot of code that just calls banked functions. Alright, did we disassemble load from ROM table 8? No? Okay. So, this component we are going to call name tables. Maybe I should call this something other than load denju name. Name table underscore. What am I using elsewhere? I'm not entirely liking the calling it name tables, because name tables are a thing for NES graphics. It's basically what they call the title, what Game Boy Color calls the tile pattern table. No, not tile pattern. The other table that assembles character cells. On the NES, it's called the name table for reasons. Maybe I should just call this string tables. Alright. Yeah, string table load functions. And then there's another routine right below it that loads from an identical table in B. We're going to call this load func interfaces with the status text thing, and I don't want to figure out what that does. So we will call these mystery tables for now. What the heck? This loads 4 from the same... Okay, I think this is in the same bank, but with a different base. We're going to call this tablebanks.asm. Then we are going to call this load.asm. We're going to have the load from ROM 4 and 8. DE equals... What is this D440? I know, but it gets overwritten, so I'm going to give it a funny name. See, I bet you there's like... See, it's... Right here, there's like a couple bytes. I bet you this is all in one file in the original source code, which we will never get unless miracles happen. And I believe that is a valid disassembly, so make min-gw32 make, sorry. And the comparison worked perfectly, so that means I forgot to add this shit, because I am a moron. Oh boy, section already exists, but with a different type. Does it not like my base address? Am I gonna find out the hard way that this was already... No. No, I'm going to find out the less hard way that I absolutely suck at saving things. Unknown symbol. Okay. I never remember the difference between 1 and 2 colons on this shit. But, okay, that builds, so we can add these 3 files. And then merge that back into patch. Merge in new files, and then modify the ever-loving crap out of them. So, in our modified version, we called that fun little thing back in system patch utils. So, the load dendru name was changed. Only load dendru name? All the other code is fine. Only... Okay, so the... okay, yeah, we did increase the 4 and 8 as well. But these guys over here, instead of loading a bank and resetting, it calls this utility, then calls the same function. So let's call this... And this is only for load dendru name. These other mystery tables are unchanged, but the actual functions that load stuff, 2 of their things have been changed into a call for patch utils limit break. And this accounts for both the 8 and 4 byte tables, which are now 16 and 8. And we moved the staging location from D440 to a D68D, which actually makes me wonder if the rest of the ROM is full of arbitrary changes just because we have this larger staging location here. So gotta change our make file again. Oh. Oh boy, we forgot to export something. You have to use 2 colons because screw you. While that's working, let's make sure there's nothing else that non-symbolically references D68D. So everybody says no. Good. Recipe for what the create process failed? Oh. Happy now, make file format. Alright, we have the completeness check. Ready to run again. And 1353. It's fixed, but what is 1362? That's 552. It appears we moved some more banks around. Great. Alright. I love doing that. 78 and 75. So I think that's the only one. And then it's 1373. 55D. Now let's just rebuild and see if that area gives us an error again. If not, I can call this done. 1373 is still off by 1. No. Load A75, reset. 3A1D, reset again. Why is this? Did I move this? I think I may have moved the actual symbol, which is what we in the industry call a big freaking no-no. Because I forgot a NOP. Alright, we're up to 1570, which is a different section, which means I'm probably going to cut off this recording now and do it again later.